Gritzi. So you might remember when we introduced monads that we also insisted on them satisfying certain laws that might have seemed mysterious at the time. So today we're going to look at monads from a different perspective, which is going to explain exactly where these laws are coming from. So the perspective we want is that of making a category of effectful functions or morphisms. So we want to think of a morphism f from A to m of b as something from A to b with m effects, right? So m is a monad and it's describing the effects of this morphism. This is usually called a Kleisli category after Heinrich Kleisli. So I'm going to put him over here, the Swiss mathematician, and see. So if this is to be a category, then that means that first of all we need to have an identity, which then is supposed to go from A to m of A, right? Well, we do have the return of the eta of this type, so this is going to be our identity. But we also need to have a composition, right? So if I put this down a little bit, so if I have an f like this, and if I have a g which goes from B to C with some m effects, then I want to be able to compose these. So first do f, then do g, and this should go from A to m of c, right? So this is our composition. So let's see if we can do this. We start in A, and I want to end up in m of c. Well, first I can use f to take me from A to m of b, right? And then I can't use g directly because that doesn't match the domain here. But if I look at m of g, then I stick an m everywhere, and then it matches, right? So if I here do m of g, that gets me to m squared of c, which doesn't match the mc I want, but I can use the join to peel off 1m, right? So that gets me a composite. But now, of course, I also have to show that if I compose with the identity, then I get the same thing I started with. And this is exactly where these laws come in. So let's remind ourselves what they are. Put them over here. Make them a bit bigger. Let's see, so we had these three laws that are talking about how join and return interacts and how join and join interacts, right? And then we also had two diagrams commuting because both return and join are supposed to be natural transformations. So now let's see if we can use these laws in order to prove what we need. So put it over here maybe. Okay, so let's check to see what happens if we compose with the identity on the left. So if this f here is the identity, then what do we get? So this is eta, that's our identity, right? Which now goes to m of A rather than m of B. Okay, and the claim is that all of this should now be the same thing as just doing g directly, right? So we want this diagram to commute. So what we typically do is we look at this and then we see what can we spot that could possibly work here. So we see that here we have an eta followed by an m of g, right? That looks a lot like this situation down here, the naturality of eta, right? So if we apply that, then this diagram here says that we might equally well start by doing a G, which takes us to M of C, and then we can do an eta, which takes us to an M squared of C, right? So this diagram commutes. Okay, and then we look, what else do we have? Well, here we have an eta followed by a join. That's exactly what this situation is down here, right? So this diagram says that we can replace that with just an identity. So if we do that, then here we get an identity, and this diagram commutes, right? And if we now read this, then this says that this whole composite is equal to this composite, which in turn is the same as just G, right? Because G composed with identity is just G. So we managed to prove one of the laws. And similarly, so that was using, for this one, we were really using this diagram, right? And naturality. But naturality we use all the time. But we see that this one was used for one of the identities, and this other one is going to use for the other identity, and this one finally is going to be used for the associativity. So this is ID right or left, and this is the other one, right? So we see that one of the laws correspond, the three laws here correspond exactly to the three laws of a category. So this construction gives a category if and only if the monad satisfies the laws. So that's one way to see where the laws were actually coming from. Right? And let's see if we can do this in Agda in another video.